In the vast expanse of the cosmos, our home planet Earth spins on its axis, a beautiful blue marble suspended in the velvet blackness of space. At least, that's what centuries of scientific inquiry, observation, and exploration have shown us. Yet, even today, in an age of instant global communication and rockets that pierce the heavens, a curious question echoes in certain corners of the internet. Is the Earth really a sphere? This isn't a new question. In fact, it's one of the oldest questions we've ever asked about our place in the universe. It's a debate that pits direct, personal observation against the rigorous, evidence-based framework of science. It's a fascinating look into how we, as humans, make sense of our world. The modern resurgence of the flat Earth idea is a captivating phenomenon, one that speaks volumes about trust, community, and the way information spreads in our digital era. Why do some people look at a photograph of Earth from the moon and see a conspiracy? This journey we're about to embark on isn't about ridicule. It's about exploration. More importantly, we will then hold these claims up to the light of scientific evidence. For our distant ancestors, the world looked, for all intents and purposes, flat. You walk out your door, you look around, and you see a flat plain extending to the horizon. Early civilizations, from the ancient Egyptians to the Norse, conceptualized the world based on this intuitive evidence. They imagined a flat disk, often surrounded by a world ocean. The ancient Greeks, with their love for geometry and observation, Aristotle then came along and provided observational evidence. He heard that in the city of Syene, modern Aswan, Egypt, on the summer solstice, the sun was directly overhead at noon, casting no shadows down a deep well. But in his home city of Alexandria to the north, a stick placed in the ground at the same time and day did cast a shadow. He used the angle of the shadow and the distance between the cities to calculate the Earth's circumference with astonishing accuracy. So, if the Greeks figured this out over 2 millennia ago, why are we still talking about it? The modern flat Earth movement is a complex social phenomenon. It began with an English writer named Samuel Rowbotham. He proposed the Earth was a flat disk centered on the North Pole. In the 21st century, these ideas have found fertile ground online, particularly on platforms like YouTube and Facebook. The central tenet of the modern flat Earth belief is a grand conspiracy. This sense of community and shared purpose is incredibly powerful. This creates an echo chamber where alternative explanations, no matter how elaborate, are favored over established scientific consensus. If you stand on a beach and watch a tall ship sail away, instead, it appears to sink below the horizon. The hull disappears first. If you live in the northern hemisphere, you can always see Polaris, the North Star, but if you travel south of the equator, Polaris sinks below the northern horizon, and entirely new constellations, like the Southern Cross, become visible. Of course, in the modern era, we have the ultimate proof. We've seen it with our own eyes, to the live high-definition video feeds from the International Space Station. It's noon in New York, and the middle of the night in Tokyo. Proponents will point to long bridges like the Verrazzano Narrows Bridge in New York, and say they look perfectly flat. The two towers of that very bridge are 1 5/8 inches farther apart at the top than at their bases, specifically to account for the Earth's curvature. Instead, they propose that the flat disk of the Earth is constantly accelerating upwards at 9.8 meters per second squared. A spherical Earth with a central gravitational pull explains this observation perfectly. The atmosphere rotates with the Earth for the same reason a fly inside a moving car moves with the car. It's part of the same system, caught in the same gravitational field and sharing the same momentum. A conspiracy to hide the shape of the Earth would have to involve millions of people from competing nations and generations, from the US, Russia, China, Europe, and more. At the exact same time, solar noon is best, both of you should place a stick of the same length perfectly vertically into the ground and measure the length of the shadow it casts. Lie down on the ground and watch the sun until the very last sliver of it disappears below the horizon. As soon as it's gone, quickly stand up. You will see the sun again. Pay close attention to the shape of that shadow as it creeps across the moon. The only geometric object that casts a circular shadow from any angle is a sphere. If you've ever been on a long-haul flight, you might have noticed the flight path on the in-flight map looks like a strange, long curve. You can test this with an orange and a piece of string. So why should we trust the conclusions of science over our immediate intuitive senses? It's because science is not just a collection of facts. It is a rigorous process for understanding the world. Cross-checked and independently verified evidence from multiple fields of study. Think of the scientific method as a powerful filter for separating truth from falsehood. If new, compelling evidence emerged tomorrow that contradicted our understanding of the Earth's shape, the scientific community wouldn't cover it up. They would be thrilled. This ability to change its mind in the face of new evidence is science's greatest strength. The GPS in your phone that guides you to a new restaurant only works because it accounts for a spherical Earth. We place our trust in the scientific method every time we fly in a plane. Accepting the Earth as a sphere isn't just about getting the facts right, it's about opening the door to a far more magnificent and awe-inspiring universe. It orbits a star, the Sun, in a cosmic dance that takes 365 days to complete. When we see a photograph of the whole Earth from space, we don't see the borders drawn on our maps. The overview effect, a cognitive shift reported by many astronauts, is a profound feeling of connection to the planet as a whole. This spherical worldview fuels our curiosity and our drive to explore. It's a world with endless horizons to chase, both literally and metaphorically. It's an opportunity to talk about what science is, how it works, and why it is the most reliable tool we have for navigating reality. Science must therefore do more than just present facts. It must tell a better story. It must tell the story of Eratosthenes and his Styx, of the Apollo astronauts looking back at their home. Skepticism is the engine of science. But true skepticism isn't about rejecting everything. The invitation is here, is the evidence. Here is the method we use to get it. We are born curious, we look up at the sky and wonder. The universe is waiting to be discovered, and the view from a spinning spherical world is absolutely spectacular.